In this video we will actually graph polynomial functions. Let's graph the function f of x equals x times x plus 2 times 2 minus x. Since the equation is already given to us in a factored form, it's easy to find the zeros of the function. So we know we would have a 0 or a root at x equals 0. If you set x plus 2 equal to 0, you get x equal to negative 2. And then if you say 2 minus x equals 0, we know we get x equal to positive 2. So in my function, I can go ahead on the x-axis, these are x-intercepts, and plot those roots. X equals 0, x equals negative 2, and x equals positive 2. We can plot those points. Also, since if I multiplied this out, I would have x times x, so x squared times negative x is negative x cubed would be my highest power of x. And notice the coefficient on it would be a negative. So as far as the end behavior goes here, since it's an odd power, we know it's like the cube equation, but it's different. It's the flipped version. So it's going to go increasing on the left side and decreasing on the right side on the ending behavior. So we know that this side is just going to go up forever. We know this side is going to go down forever. We've just got to figure out what happens between now. So all I can have to do here is actually, well, we know turning points and stuff too. So we actually know that this is going to graph downward on this side, and that this will graph upward as well. So let's just do a couple of T-chart points here to kind of figure out how to graph those points in the middle there. So if I use negative 1 and positive 1, if we plugged in negative 1, that would give us negative 1 times, let's say negative 1 plus 2 would be 1. And 2 minus negative 1 would actually end up being 3. So negative 3 would be my point there. If I plugged in 1, I would get 1 times 3. And then 2 minus 1 would be 1. So I'd get positive 3. So here's the graph of my polynomial function. You can do as many points as you want to make it look prettier, but that's all you actually need for that. Let's try another one. First of all, this polynomial is not in factored form, so I will need to try to find some roots, possibly using the rational roots theorem. Let's see what we can do. The rational zeros theorem. P over Q, my possible rational zeros or rational roots would be the factors of 2 over the factors of 1. So 1 and 2 are my only possibilities here. So let's try positive 1 and see if I can extract a root. So 1x cubed, 2x squared, negative 1x, and negative 2. Let's see if that gives us a 0. So 1, 3, 2. And it actually does work. So x equals 0, x equals 1, I'm sorry, is one of your x-intercepts or your zeros or your roots. And that would diminish my equation down to an x squared plus 3x plus 2 equals 0 equation. Solve that. That will actually factor is to x plus 2, x plus 1. And so we would extract x equal to negative 2 and negative 1. So that's our other two zeros, negative 2 and negative 1. The ending behavior of this graph, your highest powered term is an x cubed. It's odd, so it's going to end like the Superman curve. And since the coefficient is positive, it's going to be up, up, and away. So it's going to be down on the left side and up on the right. So we know for our graph that we're going to be going down and then up. We know that much about it. So let's see if we can figure out what happens between. One thing we can do is find out where does this cross the y-axis. We need to do a y-intercept. Your y-intercept is if you let x's be 0. So you'd have 0 plus 0 minus 2. So your y-intercept is at negative 2. I'm going to go ahead and plot that. And so the only thing I really need now to finish out my graph is to know how far up to go in between negative 1 and negative 2. We know it's going to be up. We just don't know how far up to go. So let's try negative 1.5. If I plug negative 1.5, I'm going to do synthetic division style, the remainder theorem, and see what I get for my remainder. So negative 1.5, so that's going to give me 0.5. 0.5 times negative 1.5, negative 0.75. Okay, so 1.75 negative times 1.5 negative, 2.625. So it's going to give me 0.625. So not quite up to 1. So over there I'm going to go just up a little bit past halfway. Plot a point, and that is my graph, guys. We found the x-intercepts, we found the y-intercept, and we know the ending behavior of the function. So we're pretty easy to spit out the graph there. In this problem, we're given a function. It says find a polynomial function of least degree having the graph shown. So in this problem, they gave us the graph. They want us to come up with the function. So a couple of things that we can tell just by the way it looks. The ending behavior, we know that our leading coefficient is going to be an even power because it's down on both sides, and that the coefficient of it's going to also be a negative coefficient. So our highest power is going to have to be an even number here. We have a y-intercept or a 0, I mean not a y-intercept, but an x-intercept, a root, or a 0 at negative 2. We know that that has a multiplicity of 2 because notice it's tangent to that intercept. So x minus 2, that's going to be an x. If you've got the x-intercept of negative 2, we know we're going to have a factor of x plus 2. We know it's going to have an even power. So at this point, I'm just going to say it's at least squared. Okay? We also have a root or a 0 at x equals 1. So that means x minus 1 had to be, and it goes through, so it's a linear factor. It's not, it doesn't have any higher multiplicity. It goes through at 1. So x minus 1. And the same thing happens at 3. So x minus 3. And that's the only roots or x-intercepts that we have. So there's actually, you could say you had 4 because you have one with a multiplicity of 2. We want the least degree, so x to the 4th, and that would mean that we would be okay. We'd have x to the 4th because it's going down. We have an even type function. My leading coefficient needs to be negative. Now we do know a point on the graph. We know that the y-intercept is at negative 12. So we know that f of 0 equals negative 12. So that might help us find our polynomial a. So if we multiply this out, we'll say a times x plus 2 squared, which we know is x squared plus 4x plus 4, times x minus 1 times x minus 3. So this is going to be some difficult multiplication here. I'm going to multiply x minus 1 times x minus 3. That might be a little bit easier to full out. Negative 3x minus 1x will be minus 4x, and then plus 3. Okay, and then we're going to multiply those two trinomials together. So let's see what we get. X squared times x squared would be x to the 4th. X squared times negative 4x to the 3rd. And then plus 3x squared. Then I'm going to multiply the 4x times everything. So plus 4x to the 3rd minus 16x squared plus 12x. And then 4 times everything. 4x squared minus 16x and plus 12. Okay? So I've got a times, I've got x to the fourth. Combining all your cube terms, you have negative 4x cubed plus 4x cubed, so those cancel out. 3x squared minus 16, that's negative 13. Negative 13 plus 4 would be negative 9x squared. $12x minus 16x is negative 4x plus 12. All right, so f of x is possibly some function a times x to the fourth minus 9x squared minus 4x plus 12. To find the a value, we're going to use the fact that we know the y-intercept, f of 0 equals negative 12. So negative 12 equals a times, if I put a 0 in for all those x's, I just get 12. So a will equal negative 1, which means my function would actually be, you can leave it in factored form if you wanted to, but I'm just going to write it out in the descending polynomial form that we've got. It's negative x to the fourth plus 9x squared plus 4x